let us verify the stability, whether it's a stable or not. Okay, we'll verify here. Okay, so the stability let us verify here. So we'll take the system y of t is equal to t into x of t. So let us consider the magnitude of y of t is less than or equal to the t into x of t, the magnitude. So y of t, the magnitude is less than or equal to the magnitude of t is okay, into the magnitude of x of t, here. So we'll say one sentence here, that is what we'll say is, suppose if x of t, the magnitude of the x of t is less than or equal to the mx is less than infinity, then we'll use if here, then the magnitude of y of t is less than my is less than infinity. Okay, so here what we can see here is here we have the y of t into x of t is here. So x of t is okay. This is for the all values of the t here. Suppose if the t tends to infinity, what happens, since you are going to multiply here by t here, since t tends to infinity, the value of y of t will become equal to infinity here. The value of y of t will become equal to infinity. So we can say that this system is not stable here. Why it is not stable? Because as t tends to infinity, the y of t will become equal to the infinity here. Okay, so you can write, so as t tends to infinity, so the magnitude of y of t will become tends to infinity here. So therefore it is not a stable system here. It is not a stable system, or it is not going to satisfy the stability property here. Okay, so it is unstable here, not a stable system, or you can say it's a unstable system here. Unstable system. Okay, because as t tends to, because it's a t is here, so if the t tends to infinity, so this also become equal to infinity here. That's why it's not a stable system here. Done. Okay, so this is the unstable system here. Done, everyone. So we got the property here. Next, let us verify the property which is called as the memory. Let us verify the next property which is called as the memory. So it is given y of t is equal to the, so t into x of t, into x of t here. Okay, so if I substitute t is equal to 0, so y of 0 will become equal to the 0 into x of 0 will get here. So the present output depends on only the present value of the input here, present value of the input. So the given system is a memoryless system here. Okay, so you can take, since the present output depends on the present output. So the present output, we can say, you can add a sentence, the present output depends on the present input. Therefore, the given system is memoryless system here. It does not have memory, or it's a memoryless system. Memoryless system here. Got it, no? So by observation, we can say it here. It's a memoryless system, or you can verify mathematically like this here. T into 0 into y of 0 into x of 0. We can verify mathematically like this here. So done. So next one is causality. So since the output depends only on the present value of the input here, so it does not depend on the past values of the future values of the input here. Future values of the input. So the given system is that it's a causal system here. Okay. So I can take. Okay. So since the output does not depend on the present output does not depends on the future value of the input here, on the future value of the input. Therefore, it's a causal system here. Causal system. So you underline what are the properties you are going to get. You underline the properties here. Okay, causal system. So done, right? Next one is it's a time invariance. Any doubts in any property? time invariance property. Okay. Then. Okay. So what the time invariance property says that, so it is given y of t is equal to the, so t into x of t. So you can observe here. So since the t is present here, so it is not a time invariant system here. In the previous problem also we have seen the same thing here. So which is the terms of the another term which is in terms of the n is there. So that's why this is also the not a time invariant system here. So if it is any n term or t terms are present in the expression, then the system will be the not a time invariant system will be there here. It will be obviously not a time invariant system. Okay. So we'll prove that one here. So let us replace first. What should we do? We should replace the x of t by the x of t minus t naught. We need to replace here. Okay. So first one is replace x of t by x of t minus t naught here. So in the x of t, you're going to replace this one. We are going to replace that one here. So let us say the output is nothing but y1 of t is equal to the t into x of t minus t naught. We'll get here x of t minus t naught. Okay. So I'm going to replace the input by this one here. So in the y of t. So in y of t, what shall we do? We'll replace the y of n by the. Okay, so we'll replace y of t, replace. So t by the t minus t naught here. In y of t, replace t by the t minus n naught here. So if I'm going to do that replacement here, that replacement, so what we'll be getting is, so y of t minus t naught is equal to the, so t minus, okay, so t naught, since t is there, so t minus t naught into x of t minus t naught will get here. So call this as equation number 1, call this as equation number 2. So compare equation 1 and 2. Compare equation 1 and 2.
Excuse me.
Yeah, tell me.
The page is not completely visible, sir.
This is visible. So I'm seeing here. You can see. You can pin me.
Yes,
okay,
now it's visible.
Okay, fine. So okay. So if it's not visible, you let me know. Okay. So thank you. Okay. So compare equation 1 and 2. So you can say it's not a time. It is not a time invariant system. It is not a time invariant system. The given system is not a time invariant system. So what are the properties you are going to get? So you underline the properties so that it will be easy for you to analyze and it will be easy for you to solve the problem here. Done, right? Done? Okay, fine. Okay, so we'll go for the next problem. So I think you don't have any doubts. So you can see by observation, you can see it here. So t into x of t. So whenever the product is present, the system will be the linear system will be there here. Whenever the product is present, the system will be the linear system will be there. And stability, since by observing the whichever the coefficient of x of t, we can identify if it's stable or not here. So since as t tends to infinity, it will become infinity here. So we can say it's an unstable system here. Okay. So for the setting memory, so since it depends only on the t here, so we can say it's a memoryless, and causality also we can see here. Whenever the term extra term is there in the output here t, so we can say it's a it's not a time invariant system here, not a time invariant system here. Okay, so I thought this is the concept of first point in on there. So for the system to be linear, only the product should be there in the output here. In the input output relation, only the product should be there. So you can say such will be the linear system here. Okay, for time invariance, if it any extra term along with the t is there, okay, along with x of t, if any t terms are there, if any function of that one will be there, we can say it's a not a time invariant system here. Okay, so like that we can observe here, and so that we can use that one for the these concepts you can use for the attaining the competitive exams. Okay, so I shared the one post regarding the GATE seminar, which is going to be held on tomorrow. Okay. So the GATE seminar that is a competitive exam. So it combines all the semester subjects here. For example, in the third semester, you are studying network theory, electronic devices, okay, logic design, that is DSLD. Okay. In the fourth semester, you're studying control systems, signals and systems, mathematics. In the fifth semester, you're going to many more subjects like that here. So it is the GATE exam is it's a combination of all the subject exams will be there. All the subjects it is going to take, and that is a competitive exam. So that by using that exam, if you are qualified, you can able to go for the IU studies. Like in the IITs, if you get very good score, you can go for the IITs or NITs. You can go. So NIT Sizafimat, National Institute of Technologies, or else you can go for the many reputed institutes in the Bangalore. You can go here so that you'll get the stipend for doing your MTech here. I think I told in the last class, right? Last class ಹೇಳಿದ್ನಾ ಹೇಗೆ regarding this one. I told or what? Okay, so if you qualify the GATE exam, okay, if you are going to do MTech in colleges like BMSCE, okay, BMSCE, RVCE, or MSRIT, or PCTR, so that you are going to get the stipend of 25,000. You are going to get per month. You are going to get the 25,000 stipend. You are going to get here. Okay, and also if you want to join for the BEL, DRDO, ISRO, okay, if you want to join for the HAL. So for these organizations, like we are going to call these as a public sector units, you are going to call. Okay, for these organizations, if you in order to take get entry for that one, the GATE is the main qualification here. If you clear the GATE exam, so that you can go for the those organization to work, you can go there here. Okay, so regarding that one, so what are the benefits of taking the GATE exam? All those things it will be there in the seminar. Tomorrow seminar it is going to be organized here. So everyone register for that one, attend for that one here. So because this is the right time, so that you can plan which are the subjects are very important for the GATE exam, and you can just have a little more concentration, so that this exam you can take after your 7th semester. In the final year you can take, or after completing the BE you can take here. Okay, so because if you know the which are the subjects will be very important for that one, so that you can have a some little more concentration on these subjects here, so that you can score very good marks in this exam also, in the semester end exam, and also in the GATE exam. Now only you can do prepare for that one. Okay, and you can maintain all the notes properly, so that it will be helpful for you to score very good marks in the GATE, and you can get entry for the any public sector units, or you can go for higher studies. Okay, so got it now? So everyone do register for that link, using that link here, and attend tomorrow's seminar. Make use of that one here. Okay, this is the right time to plan your career, because these are okay, offline, online classes are there, so we'll be having enough time. So plan accordingly and do execute here. So any doubts regarding that one? To build your career, you can ask me.
Sir, how will be the toughness of GATE exam, sir? Will it be like CET or will it be like JEE?
More than that one. It will be more than JEE. Okay, so if you are good in the subjects, so first one is basic is mathematics of all the subjects. The book is Gravel book, you know mathematics, right? That one. Next one is the subjects from the third semester. It is ED, electronic devices, network theory. Okay, so and the power electronics, electronic instrumentation and power electronics is there. So that one DV, that is digital switching, something is logic design. Okay, so that one DSD. Okay, digital system design, right? In the fourth semester, signals and systems, control systems. Okay, so microcontroller, some part will be there. Probability, engineering, statistics, some part will be there. In the fifth semester, so if you come, so it will be the digital signal processing will be there, ITC will be there, PCS will be there, the principles of communication systems, and Verilog will be there. If you go to a sixth semester, in the sixth semester, digital communication will be there, and something satellite communication. So only little part will be taken from the sixth semester here. Seventh and eighth semester, only some small subjects will be taken here. Okay, so mainly from the third and fourth semester, maximum number of subjects will be taken here. So if you know that one, okay. So as I told now, if you look into this problem, you should be capable of telling which are the properties it is going to satisfy here. So like that, if you are good in this one, so that you will be able to take up the GATE exam easily, you can take up here. Okay, so that one, tomorrow we are going to organize the seminar. So from the GATE Institute, that is called the Home Institute from the Hyderabad. Okay, so you can attend that one, so that you'll get the idea. Okay, if you are dreaming for working in the ISRO or DRDO, so you know recently DRDO has launched the medicine for the COVID, right? Searches for the COVID. So if you want to be the so if and ISRO, they launched a rocket to the moon. So many things are there. So if you want to be one of the part of that one, okay. So if you want to be the like proud to be working the such a public sector units like HAL, ISRO, DRDO, all those things. So it's the right time to plan now itself here. Okay, so we are there to guide you, but only thing is you should have the interest and you should ask the faculty. I should ask anyone whomsoever you know. Okay, so attend the seminars whichever you are going to make, that is for your benefit only. Okay, for your future benefit only. So try to attend that one. For your seniors, 6th semester, we have organized some placement training we organized. Right now it is going on for them here. So we'll provide each and whichever where we need to provide what things, we'll be providing at the regular times. But only one thing is that you should make regular usage of that 1 year. Okay, whenever the opportunity comes, you should use it. That's it. It is coming free of cost. There is no need to pay any amount here. So just you attend here. And I think if you can ask your seniors, those who are in the 8th semester, so those who scored very good marks in the semesters. Okay, so one of the 8th semester student, I think Yatish. Okay, another one girl Sindhu. So from them, yeah, they scored the highest marks in the from the first semester to the 6th semester. So based on their marks, we are recommended them for providing the free coaching GATE classes for them here. Okay, so we are recommended for them in the Vani GATE Institute. You might be knowing in the Bangalore. We recommended for them here so that they got the free materials they got here and even the free GATE coaching materials and free coaching they are getting here. So for GATE coaching, the cost will be around 80,000 will be there. So that we made easy, free of cost. So what are the materials they got? The cost of the materials itself is around more than 10,000 rupees is there. Okay, so that is a help we are doing from our department. Okay, so but only thing is that you should have interest. That's it here. You should have interest. You should approach the faculties. Okay, so we'll provide everything for you people. So tomorrow we have the seminar. Make use of the seminar here. So after that, if you have any doubts, you can ask me in the class. We'll be there to help you. Okay, so you can ask if I'm telling. Okay, you can ask your seniors. So by name Itish is there, Sindhu is there, and many of them we have recommended, and they have given the discount for them for the GATE coaching here. Okay, so the whatever the book you got is around more than 10,000 rupees materials he got here. Okay, so fine. So tomorrow, register everyone, attend the class. Okay, so thank you.
So but will classes be there tomorrow when seminar is going on?
So 11 from 11 to 12:30 it will be there. That's it here. So class will not be there from 11 to 12:30. Okay, so you can attend that seminar. Okay, so fine. So take the next problem. Y of n is equal to x of n plus u of n plus 1. Okay, so by observation, I will say this one. So this is not a linear system. It's not a linear, and it has a memory. It has memory here, and also it is a non-causal system, and it is not a time invariant system, and it's not a stable system. Okay, so by observation, we'll say here, let us verify that one. So just I've taken the question. Okay, I've not done this problem practice early. So just by observation, I'm telling here, let us look into that one here. So first, let us take the linearity property. First one, linearity property. Okay, so in the linearity, so we have y of n is equal to the x of n plus u of n plus 1. So I can take let x of n is equal to the a1 into x1 of n plus a2 into x2 of n. Let us give that as the input here, so that we'll get call the output as y of n only. So it has become a1 into x1 of n plus a2 into x2 of n plus u of n plus 1 you're getting. Call this as equation number 1 here. Okay, next let us give h of a1 into x1 of n as the input here. A1 into x1 of n, the output you are going to obtain as a, so it is y1 of n. This y1 of n will be equal to the, so a1 into x1 of n, that will be added with the u of n plus 1 here. The system operator h is nothing but what is u of n plus 1 here will be added here. Okay, so similarly give the input as x2 of n into 8 of n, so the output is called y2 of n, which will be equal to the a2 into x2 of n plus u of n plus 1. Now add these two things here, so y3 of n will become a1 into x1 of n plus u of n plus 1 plus a2 into x2 of n plus u of n plus 1. So call this as equation number 2. So compare the equation 1 and 2. This will be exactly same should be there. If it is not same, we'll call it as a non-linear system here. So that's it you need to do for everything here. So compare equation 1 and 2. Compare equation 1 and 2 here. So therefore, it is not a linear system here. Done. Done.
Excuse me, sir.
Here, tell me.
Sir, the other day you told that we can submit assignment after IA.
Yeah.
But in Teams, we have not updated the last submission link, no, sir.
Okay, I'll update that.
Okay, sir.
I have forgotten. I'll update.
Okay, sir.
Take next one, stability. Okay, take the stability. Consider the done. Okay, so I will consider the equation y of n is equal to x of n plus u of n plus 1 here. So we'll consider the magnitude here. The magnitude is less than this one. Whenever we consider magnitude, it will become like this. So now you know that u of n plus 1. So u of n plus 1 is the thing, but it is equal to the 1. Okay, from a to 1, this will be equal to 1. From a to where it will be equal to 1. What's the value of u of n plus 1? So u of n is nothing but 1. It is from the minus 1 up to the infinity will be there here. Minus 1 is less than or equal to n. Is less than the infinity, it will be equal to 1 will be there here. So when you're going to add 1, so this is for the all values of n here. When you're going to add 1 from the all values of the n here, so this will become equal to the, obviously it will become infinity here. Okay, when you're going to add this one here up to the infinity, this will become equal to infinity, so that the given system is it's not a stable system here. Okay. So right. Okay, fine. Okay, so just a small correction here. Okay, so u of n plus 1 is equal to 1 from minus 1 to the infinity is there here. Okay, so small correction. So suppose if summation is there, so then only it will become equal to the infinity here, because it's not summation is there. No, if I submit n is equal to the particular value, say something n is equal to 1, so you're going to get this value will be equal to the corresponding answer you're going to get here. Okay, so since u of n plus 1, okay, it is bounded here. Sorry, just it is bounded here. It is bounded with the value of n here, with the value of n. Okay, value of n here, so that u of n plus 1 is equal to, if you consider the magnitude at any particular value, it is 1 here, so that this system will be the stable system will get here. So sorry, I thought this is a summation, I thought here. So summation is not there, just it is the stable system will got here, because when I substitute n is equal to 0, the values will be taken at corresponding time interval only. If I take n is equal to 10, it will be taken at 10 only. If I substitute n is equal to infinity, it will be taken at infinity only. So at infinity, it will be 1 will be there. So if I'm going to sum up this plus this, if this is a finite value, obviously this will be the finite value will be there here. I thought it's a summation is there, so it's not a summation. Okay, so we can say it's a bounded system, we can say. So we can take this one here. So since u of n plus 1 is equal to 1 from this one, and u of n plus 1, it is bounded with the value of n, with the value of n here, with the value of n. Therefore, the given system is stable system here. Stable system. Got it now? So sorry, just confused here. Okay, it's a stable system here. Done. Done, right? It's a stability. So next, let us verify for the memory. Okay, so let us verify for the memory. Let us verify for the memory. So this is, we have y of n is equal to, so it is a x of n plus u of n plus 1 is there, y of n plus u of n plus 1. Okay, u of n plus 1 is there. So let us verify the memory here. So let if we substitute n is equal to 0, so it has become y of 0 is equal to x of 0 plus u of 1. So this is the input signal only, and this is the some extra constant we are going to add here. Extra constant we are going to add here. So we can say the present value of the input output depends on the present value of the system. So the system is said to be the memoryless system here. The memoryless system here. Okay. So I can take since the present output. Okay, for if you are any confusion in the memory, you can substitute the value of n corresponding to, you can substitute here and you can verify the answer here. Okay, so it should depend on the input signal here. This is the input signal here. Okay, so if it depends on the present input, fine. If it depends on the past input, we can say it's a system is said to have the memory, you can say it here. Okay, so since the present output depends on the present input, therefore the system is a memoryless system here. Therefore the given system is a memoryless system. Memoryless system. Memoryless system. Done. The given system is a memoryless system here. Done.
Yes, sir.
Okay, so let us go for the next one. The next property, which is called as a causality. Causality. So here it is y of n is equal to x of n plus y of n is equal to x of n plus u of n plus 1. Y of n is equal to x of n plus u of n plus 1. So, okay. So you can see that if I substitute n is equal to -1. So since the present output depends on the present input only, it does not depend on the past input here. For example, if I substituting y of n here, so n is equal to 0. So this has become x of 0 plus u of 1 here. So it depends on the present input only. So the given system is a causal system here. It is a causal system here. Okay, so you can take since the present output, since the present output does not depends on the future values of the input here, does not depends on the future value of the input, future value of the input. Therefore, it's a causal system here. It's a causal system. Okay. It's a causal system. You can see it. Yeah, you can see now. It's a causal system. Done. Next one is memoryless causality, or next one is the time invariance here. Time invariance. Time invariance here. So it is given y of n is equal to the x of n plus u of n plus 1. So let us replace x of n by x of n by x of n minus n naught here, x of n minus n naught. So that will get x of n minus n naught plus u of n plus 1 will get here. Okay. Next, let us replace n by the n minus n naught, so that it will become y of, let us call this one as the y1 of n here. So this has become y of n minus n naught is equal to x of n minus n naught plus u of n minus n naught plus 1 here. So call this as equation number 1, call this as equation number 2 here. So compare equation 1 and 2. Okay, so let us compare equation 1 and 2 here. Compare 1 and 2. So the system is not a time invariant system here. Not a time invariant system. The given system is not a time invariant system. Okay, so done right. It is not a time invariant system. Done. Okay, so any doubts in this one? the system properties. Okay, so similar to this one, so t into x of t, you can do another problem as homework here. So you can take another problem as homework here. So take y of n is equal to, so take the fifth problem, y of n is equal to n into x of n. You can take it as a homework, you can take here. Take this one as a homework and do that one. Okay. So right, take this as homework and do that problem. Okay, fine. So let us take the next problem. So y of n is equal to x of minus n, or we can say y of n is equal, sorry, h of x of n is equal to x of minus n. So sometimes they will give like this also. So h is a system operator, or sometimes it is they're going to give as a t, they will give you. Okay, so it is equal to x of minus n. The system operator is, it is going to include the time shift, it is going, time reflection it is going to introduce in the input signal here. Okay, first let us verify the linearity property here. First let us verify the linearity property. Okay, so let us the given system is, so y of n is equal to x of minus n, or we can say h of x of n is equal to, whenever you're going to give the x of n as the input, the output will be the time reflected sequence you're going to get here, time reflected sequence. Okay, now let us substitute x of n is equal to, so a1 into x1 of n plus a2 into x2 of n here. When I give this one, the output, wherever n will be there, the n will be replaced by the minus n here. So that the output we are going to get y of n is equal to the, so a1 into x1 of minus n plus a2 into x2 of minus n will get here. Okay, so a2 into x1 of minus n plus a2 into x2 of minus n will get here. So done. So call this as equation number 1 here. Next, let us give the individual input here. So let h of a1 into x1 of n, I'm going to give as the input here. The output you are going to get as the y1 of n. So this will become equal to the a1 into x1 of minus n. a1 into x1 of minus n. So similarly, I'm going to give a2 into x2 of n, I'm going to give as the input here. The output will be y2 of n is equal to, so a2 into x2 of minus n. Let us find out the system, that is y3 of n is equal to, y3 of n is equal to, so it is a1, that is y1 of n plus this one, a2 of n, a2 into x2 of minus n. So this will be the y2 of n. So call as equation number 2 here. So compare equation 1 and 2. Compare equation 1 and 2. Compare equation 1 and 2. So we can say that, so since y of n is equal to the y3 of n, the given system is a linear system here. So it is a linear system here. It's a linear system. Okay. The given system is a linear system. Done, right? Next, let us verify the second property, which is called as the stability. So if you have any doubts in any property, you can ask me while doing stability. So stability, let us take the system equation. Y of n is equal to x of minus n. Let us consider the magnitude. The magnitude of y of n is equal to the, so it's less than or equal to x of minus n. Yeah, tell me.
It's not visible, so stability part.
Yeah, so you can see now. Now you can see, I guess.
Yes, sir.
Okay, fine. Okay, so y of n is less than or equal to the x of minus n here, x of minus n. So okay, so the input at n is equal to 0 depends on n is equal to minus 0 here. So you can say it's a stable system. We can say it here. Why? Because suppose if that is x of n, okay, the magnitude of x of n is bounded with the value mx here is less than the infinity. This is for the all values of n. Okay, for either n can take the positive or negative value. If x of n is bounded here, so if x of n is bounded, so then y of n is also going to be bounded as with the finite value. So for the all values of n here, so therefore we can say it is a stable system here. It is a stable system. So this is for all values of n here. All values of n. So if it is bounded for the all values of n here, so means either n can take the positive or negative value. If it is having the finite value, then we can say y of n is the bounded. So therefore it is a stable system, we can say it here. Okay, so got it now. So here we are going to use the reverse here we are going to use for the r involve this one for all values of n here. For all we are going to use here. So right, so this is the stability. Okay, so we'll go for the next property. So next one is the memory and causality. Okay, so take the next property, which is called as a memory or memoryless, we will call here. So it is given y of n is equal to the x of minus n, x of minus n. So let me substitute n is equal to 0. So we got y of 0 is equal to x of minus 0 we got here. Let us substitute n is equal to the something called 1. So y of 1 is equal to the x of minus 1. Okay, x of minus 1. So if I substitute n is equal to 2 or n is equal to minus 1, so you can say y of minus 1 is equal to the x of plus 1 here, x of plus 1. So you can see the present value of the output depends on the some past values here. For example, this is a minus 1 I'm substituting here. This is the past value of the input here, past value of the input here. So you can say the system is said to have the memory, we can say here. Why? Because it is depending on the past values of the input here, past values of the input here. So it is a memoryless system here. Okay, it's a memoryless system here. So that okay, the given system is said to have the it is not a memoryless, it is said to have the memory here, because it is depends on the past values of the input signal here. So we can say the given system is okay. So since you can take, since the present output depends on the past input samples, past input, therefore system has memory. We can say it has a memory, or else we can say it is not a memoryless system, not a memoryless system. So both are on the same. It has memory or not a memoryless system. So both are on the same here. Okay. Done.
Yes.
Yeah. So next one is causality. Okay. So causality. So you can same way we can verify here. So if I substitute n is equal to 1, so y of 1 depends on the x of minus 1. If I substitute n is equal to 5. Okay, so let us say this is a present value and it depends on the future value. Let us say this one is the future value. So it has a and also you can see directly, you can see y of n is equal to x of minus n. X of minus n is the thing, but it will come to the negative side here. So whenever it comes to the negative side, okay, so these are nothing but the past values of the input here. So past values. Okay, so this is exactly the present value, and these are nothing but the, so these are nothing but the future values here. Future values here. Okay, so you can say these are present exactly here, it's a present here, these are past and futures here. So x of minus comes means it is a future value. So you can say since the present output depends on the future value of the input, so you can say it's a not a causal system here, not a causal system. Okay, so getting right, we can take since the present output depends on the future value of the input, depends on future value of input, future value of the input, therefore it's a non-causal system. It's a non-causal system. Non-causal system. Okay, getting right. So you can substitute the values of the n here and you can declare this one based on this concept you can use here. So next one is the time invariance. Time invariance. right? So we have the system. It is given by y of n is equal to x of minus n. So what we'll do is, so replace, first we'll do replace the x of n by x of n minus n naught, so that this will become, so I'm going to write here, so y of n will become x of minus of n minus n naught here. So this has become equal to the x of n naught minus n will get here. So when I multiply minus here, it will become x of n minus n naught will get here, or minus n plus n naught, both are one and the same here. Okay, so let us call this as the y1 of n here. Similarly, what we'll do is we'll replace n by n minus n naught in y of n, n minus n naught in y of n here, so that it will become, so y of, okay, so n minus n naught is equal to the, so when I'm going to replace n by n minus n naught here, so this also become n minus n naught. So this is equal to the x of n naught minus n here. So call this as equation number 3. This called 3, and this one you can call it as a 4. So compare equation 3 and 4. Compare 3 and 4. Okay. So the given system is it's a both one and the same here. Therefore, it's a time invariant system here. It is a time invariant system. Okay, it is a time invariant system. But any doubts? Okay, so take some 2 problems I'll give.